In this short video, I'm going to talk about the hypernatremia and how we can actually derive the formula of correction for hypernatremia from first principles. If you go to the internet, you find a number of resources of the correction of hypernatremia, the amount of fluid deficit. And the formula that is usually given is this one, as you can see from here, is that the water deficit or the fluid deficit is actually equivalent to the total body water, which is equivalent to 0.6 or 0.5 to 0.6 times the body weight times the measured, this is the measured plasma sodium divided by 140 minus 1. Okay, so this is the formula that is usually given either in videos or in the articles from the internet, right? And similarly, here you can see the same formula. The estimated water deficit is given as the total body water times the serum sodium divided by the 140. Now, what is 140? This 140 is basically your desired serum sodium, right? So which means that since the range is about 135 to 145, we'll take the average of 140 millimoles. This is the serum sodium that you measured minus 1, right? So the formula will be of course, the total body water here will be equivalent to 0.6 times the body weight. Why 0.6? Is because the 0.6 or 60% of our body weight is actually the equivalent to the total body water, right? So, so you have 0.6 here times the body weight divided by your measured serum sodium. Let me remove some of these things first. Divided by your desired serum sodium minus 1, right? So this is the formula that is usually given. And the caveat here is that the recommendation is to correct it at a rate of 0.5 millimole per liter per hour, or which is equivalent to 12 millimole per liter per day, right? Because of the 0.5 times 24. So no more than 12 millimole per day over the next 24 hours. Or some will put it about 6 millimoles, right? 6 millimoles. So it's about 6 millimoles to 12 millimoles per day. The amount of reduction. So we don't reduce it drastically because that will cause effects of cerebral edema, right? This is also in line with the concept of no more than 6 per day. As in the case of hyponatremia. So if you don't increase it more than 6, in the case of hyponatremia, you don't increase more than 6 millimole per day. You also, for the case of hypernatremia, that we don't reduce it more than 6 millimole per day. So most reference will give it about 6 millimole to 12 millimoles per day of hypernatremia. But the issue now is that how do we actually derive this formula from first principles, right? Where do you get that formula that I have shown earlier on? Because if I don't find it, if I'm not able to derive the formula or explain or understand the formula, I find it very hard to commit to memory. Like this formula here, which I have written earlier on, 0.6 or 60% of the body weight divided by your measured serum sodium. Divided by 140, which is your desired one, minus 1. Okay, where do you get this formula? How do you get this formula? But if I'm not able to understand this, then I will find it very difficult to commit to memory. I have find a way to to understand this, which is not being discussed in the videos that I find in the internet. Imagine that you go to a restaurant and you order a soup, right, and you find that the soup is very salty. Oh, very, very salty. Okay. So if the soup is very salty, what do? You add water, right? You add the water into it in order to dilute the concentration so that it's more palatable, it's not so salty for you to drink. Okay, so this is the same concept that we will use. Right. So this is a formula for hypernatremia, just as I mentioned earlier on. 6 a day makes sense for safety. So 6 hours for severe symptom. In other words, if you have a severe case of hyponatremia, then you correct or increase 6 millimole in the next 6 hours, and then you stop, and you would repeat your BUSE results, BUSE test again. Right? Otherwise, it's 6 millimole. You increase by 6 millimole per day. Okay, now back to the illustration of the drinking a soup, which is very salty, and you will want to dilute it with water in order to make it more palatable. Now, imagine that now here we have a beaker, and at the bottom here is the amount of salt. Right? This is salt here. Okay. And this is the amount of water that is diluted into it. And so this would represent your current body water. Okay, as I will put it here, CBW will be your current body water. Okay, this amount of salt inside here, right? If you find that this is very concentrated, what do you do? So you will have to add more water into it. Okay, and when you add more water into it, you have a new body water. So this is the amount of salt is still the same, right? The amount of salt inside here is still the same for both. In both, this is pre and this is post. Right? So this will be represent your new body water. But we know from first principle that concentration of any solute, right, is equivalent to the mass divided by the volume. Right? So this means that the mass equals to your concentration times the volume. Okay. But we know that the mass here, the amount of the mass of the sodium, or the mass of the salt here, is actually equivalent to this pre and the post is actually equivalent. So we have a concentration of serum sodium here. Let's call it the measured serum sodium, right? And now when you add water, you have a new serum sodium concentration. So you call this the desired serum sodium concentration. Okay, this is the measured serum sodium concentration. But we know that the mass is equal. So this means that the current body water times your measured serum sodium is equivalent to your, let me write it better, new body water times your desired serum sodium. All right. So water deficit is equivalent to your new body water here, new body water minus your current body water. This will be the amount of fluid deficit. This is the amount of fluid deficit or water deficit. The amount that you need to add inside there in order to dilute it to a certain concentration, a concentration that's acceptable, that's desired, that's palatable in the case of a soup, right? So, but we know that the new body water here is, okay, let me remove this. based on this formula here, based on this formula, right? The new body water is actually equivalent to your current body water times your measured serum sodium divided by your desired serum sodium. Okay. So now you replace this new body water, this one, into your formula here. Okay, it means that it will equal to your current body water times your measured serum sodium divided by your desired serum sodium minus your current body water. And this is equal to your current body water measured serum sodium divided by your desired serum sodium minus 1. So there you go. So this is the formula that you will get. Of course, you to put down your desired serum sodium, you can replace it with 140. There you go. So this is the formula that you will often see, right? So we can actually derive this formula from first principles, and that will make it, when we are able to appreciate, we are able to understand how the formula comes about, then we'll easier to commit to memory. So that's all for this video here. Thank you very much for watching this video. I hope you find this helpful.